taking the learnings. So, um, so as you can see, we went from steam power, from human power before Industry 1.0, all the way to using technologies like Internet of Things, AI. We have blockchain technology. We have smart contracts. There's so many things that are that are either impacting us today that we don't know about, or it will impact us in the very near future that we will be that we're blown away by. And ChatGPT is a very, very small example. Now, the fun thing about ChatGPT is every interaction you have with it, it learns. That's where its intelligence comes from. It's interacting with you and learning from you at the same time. But also remember, when you go to ChatGPT to write some questions and answers from our classes, ChatGPT also lies a lot. So you better be very careful. And now there are tools that can identify whether what you have written in your exam or what paper you have submitted, whether it came from ChatGPT or not. So there is a counter to everything. So just be careful. But when we look at these new technologies, these fantastic new beginnings in Industry 4.0 with AI, with Internet of Things, with 3D printing, with higher and better precision in manufacturing, nanoscale level accuracy in manufacturing, driven by oh, uh, we would what would be next if is this it is Internet of Things, is it AI, is that the final frontier for manufacturing? My belief is the next level of engineering, the next challenges will be solved not on Earth, not on terra firma, it will be in space. We are still manufacturing everything here. We're still not manufacturing up in space or you can actually process with even titanium, which is not exactly equal in terms of strength to the raw titanium that is available to you, but it still does a fantastic job. And then we come to stereolithography, which uses resins, a laser, UV laser, and it makes a very functional part with a beautiful finish, with beautiful look, and it is actually used to make molds in industry today. In fact, we sold a CNC machine to a gun manufacturer, a person who wants to manufacture guns. He has a license, and he filed patents, two patents, one for a mechanical firing mechanism and one for something else that I don't know. But he actually bought our machines to make functional prototype, not fully functional, but near functional prototypes based on what he was able to make using SLA process. And it's a fantastic contact that we got, and we actually went to his city to deliver training to his employees, met with them, got them hooked on machining, and I'm absolutely sure, I think in 1.5 years, we'll see their products on the market. Now, this is really amazing. We have an Indian company that is now making, I think they first ran their test of a 3D printed rocket engine in India using a German metal 3D printer, and I believe they have since then made their own process as well of making 3D printed metal engines. And you have to consider the fact that this thing can take the enormous forces of a rocket engine, of a rocket propellant, and they are not using, they're not removing tons of material. So CNCs is basically called subtractive manufacturing, because you take a block of metal or material, remove as what you don't want, and then get to the desired shape. Subtractive manufacturing is adding layer by layer what you want in the shape that you want, and it's much more efficient in terms of material use. So even though the properties of the finished material are not exactly the same as the original or the raw, but it's still extremely good enough that it can manage the stresses and strains of the rocket launch or the propellant being burned. And then something what Mr. Girish would enjoy, 3D printing houses. This started in the West a few years back, and IIT Madras, this is a company that is based out of IIT Madras, they took that concept and they made it in India. And it's a special mix of concrete. It is not your normal concrete, which has a very high amount of moisture or water content on it. Because when you see concrete being poured anywhere near in a neighborhood, you'll notice that it's very runny. This concrete is a special mix of cement, sand, geopolymers, and fibers. And it allows, what does it allow you to do? As you can see from this example, it's a nozzle which is pouring concrete in, and you can do it at your defined speeds, depending on the mix of the concrete. And within a certain amount of time, a very, very short amount of time, it can build whatever blocks that you want to build, whatever shapes you want to build. And imagine that and the shape of the house is limited only by your imagination, by physics, by gravity. If you can think of it within those constraints, you can make it today. And at its core, what is it? It is nothing but a positioning system in a three-dimensional space with high accuracy. Only the material gets poured from that spigot. So technology, 3D printing technology has come a long way from labs, and it happens. This is what actually happens every time. Technology gets born in a lab. It is found out eventually by someone who is very passionate about it. It spreads like anything, and then you get something like this. So this is extremely inspirational for us in the industry, in the manufacturing sector, to see things like this, things like newer materials being used. And I'm very proud to say that, carbon fiber and fiberglass and composites we are the world's first to make a CNC machine out of it. Now, this is not just, so 3D printing, even though it's old, it is being implemented in newer ways, in newer fields, and a lot of innovation is going there. Because you can't build such pieces, these pieces with modeling, with software modeling, with 3D modeling. And even in 3D modeling, 3D softwares are getting smarter by the day. They are also evolving using machine learning to understand what shape can take what amount of stresses in what configuration, calculate that for you, give you a direct input while you're designing it in the software before you actually build it here. And a lot of these technologies are now converging into a very different space as well, which you probably don't think about. So warehouses are an integral part of our life today. You may not realize it, but every time you order something from Amazon, there is a person who finds the product in the warehouse, picks it up, gets it to the delivery station. There it gets sorted like a post office, goes to the person who needs to go to that particular area, to your particular area, put it in his bag, drag it all the way there, drag it to your house, to your doorstep, and give it to you. Now, logistics is the backbone of any industry. And efficient logistics, where parcels don't get lost. Now, because there's a human touch, there's always going to be errors in human interaction, in how we position things, how we place things. Things get lost. Even though Amazon may be 99% efficient, it's still 1% inefficient. And all the new technologies of artificial intelligence, of machine learning, of precision positioning, and I'll show you what all technologies go into making this possible. These can be autonomous robots, or these can be robots that follow a set path every single day, every single time. Or these can be robots that just need to pick one thing from here, put it there. So, what brings about a convergence of such a warehouse, such a convergence of such broad technologies into one building where everything, there is not a single human touch either. I have seen Chinese warehouses where the boxes come out of the ground, picked up by the robots, taken to wherever it needs to be. Positioned 50, 60, 70 feet high, 80 feet high, depending on when it needs to be ordered, when it needs to be sent. So, the example of warehouse automation we saw is a convergence of digital process automation and physical process automation. Taking things that have existed in both the software realm and the hardware realm and bringing them together with innovative ways of attaching them. You can take a robot which has just a small processor, which knows how to do just one thing, and bring it into a more modern workplace with innovative new software technologies. So because this is so much, I don't want you to read everything and get confused by it. So I basically broke this down into four different segments. One section of this is data. Your software applications, APIs, your cloud database is nothing but pure data. Data which is structured, which is constantly available. And then that data needs to get analyzed. The command and control systems need access to that information to be able to tell what to do in the entire warehouse whenever it's needed. And persistent communication. You need your mobile phones, tablets, smartphones, internet networks, networks within the environment itself to be able to talk to each device whenever the need arises. And solution-specific hardware. You may notice in the past video, they were using a certain selection of robots, a certain selection of types of robots. Your warehouse may need just one or two of them, or it may need the whole gamut of this. So it comes down to what need you're trying to fulfill, that you can bring all these different technologies together and create something called an automated warehouse that may not even require any human interaction, any human intervention at all. Self-learning and self-healing was talked about a little bit. That's where these things come on. If something falls down, there could be robots that come in and pick that up because there's an error. There are cameras looking everywhere. They can position what has fallen down in extreme precision location, extremely precise coordinates, send the robot, pick it up, and go on again. But even those errors are 1 in a million and 1 in a billion kind of. Now, it's very exciting to see something on one extreme, which is complete automation. But companies that have existed for hundreds of years, or 70 years, 80 years, how do they transform? How do they bring in technologies to reinvent their way of function, to reinvent their processes, to reinvent what they do day in and day out, and to do it efficiently? So Volkswagen is basically going on a transformation journey in its factories and its supply chain environment by utilizing cloud-based factory apps, AI tools, and collaborative robots, or called cobots. Cobots is basically robots that interact with humans. So if something needs to come to a human operator, a robot can bring it or take it away from a human operator. So they have chosen not to replace their entire human population of workers, but in a collaborative environment, in a collaborative way. That itself requires a lot of programming knowledge, a lot of programming challenges to overcome. Your AI tools are being used in the factory environment for people development. They are not being used to get rid of people, but to make them better, to identify where they are, to perform failure analysis, to perform process automation and see where challenges exist, get them trained, get them retrained, and get them better. Then they have also connected their entire supply chain to their industrial cloud that runs on Amazon Web Services. And the reason to do that is so when they are doing manufacturing using their robots, using their systems, using whatever supplies that come in, and they build their vehicles, they can get robots, they can use artificial intelligence tools to analyze which part was defective during the assembly process. They can do post-assembly checks very, very efficiently and much more accurately than anyone else. Using optical analysis, you can set parameters that this welding should be only this thick, or the assembly or the torque in each nut that has been done, is it matching or is it exceeding the parameters set in the system? And down to that level of efficiency, that level of accuracy in data and information can be fed back to your supply chain partners and drive efficiency gains over and over, year over year. With Volkswagen making millions of cars every year, even a $10 improvement per car translates into $100 million savings per year. So that's the level of work that is happening in large organizations. So new technologies are helping even large organizations in a very substantial way. Automated quality checks, skill enhancement using AI tools, supplier quality, all of that is getting transitioned. And now there is rethinking what traditional manufacturing is also doing. So CNC machines, especially vertical milling centers that you see here, they are also embracing this change of automation, of artificial intelligence, predictive analysis. And what they're trying to do is they're trying to make the entire manufacturing using vertical milling centers extremely efficient. Less time consuming to set up parts, less time consuming to store those parts, less time consuming to change the stock on a given pallet. So if you are in mechanical, right, you can see The stock is the stock is positioned, or if you have used a CNC, you probably understand that you have to position the piece accurately. You have to measure where it, and you have to tell the machine where that piece exists, that material exists in three-dimensional space for it to start working. You have to define its Y position, its X position, its Z position. Then you have to give it a command and say, this is how you need to make this part. That is ordered by software. Now, what what this company called Heller is doing is, it is saying you have one person set up 100 pallets or 20 pallets with the stock. You don't worry about anything else, and you put it in a queue. This can be a linear queue, meaning the robot picks it up, places it, and it goes in a straight line, or it can be a robot like this, which has everything around it, and it simply changes. It takes out the parts that are done. It will take the raw stock or the pallet with the raw stock, put it back in the machine, let the machine go on. So what you have is continuous manufacturing. Now, this is very impressive by itself. However, they're not stopping here. They have done something called tool automation. Instead of every machine having all the tools, all the bits, all the different types of cutting tools that it needs, you can now have a central tool repository where if one machine is using one tool, the other machine does not need not have the stock of that particular tool. That tool can come from a central repository, meaning that you don't. If you have 10 machines, you don't need to have 10 different pieces of that cutting material, of that cutting bit. You can maybe only have 2 or 3, or you can have multiple of the ones that you use the most. You can have tool transportation between machines. It is happening automatically, depending on requirement, depending on what job you are running. It can send the right tool to the machine to get affixed and then perform the work. And more important than that, because you're using the same tool multiple times, what happens is it degrades. Because it's also made of metal, it will chip. It will have issues, performance issues after a certain amount of time, certain amount of hours of operation. So they perform automated tool inspection to identify what needs to be replaced and when it needs to be replaced. And a lot more. You definitely go and just read about it. And then I come down to all of this. How does it translate for me? So today, our competency is, our machine's competency is to mill non-ferrous metals. Except for iron, steel, and mild steel and titanium, our machine can mill or work on any other material that exists. We make it from modern materials like composites. I hope I can get that news back. Supply chain independence. We are trying to also see whether removing China from our logistics system, getting nearly up to 75% of our parts coming from India or India-made manufacturers, using as less imported parts as possible and making fantastic products for our customers in our country. And what can I take away from all the all the enhancement that has happened in the industry 4.0 that I talked about? We can enhance products by using ATCs, be able to build ferrous materials in the near future, make horizontal CNCs instead of vertical CNCs. It's a complementary machine, and then go into 5-axis machining and more. And what I can integrate from the industry 4.0 is maintenance scheduling for our customers based on the travel time of our vehicle guides, of our all screws. After how many number of hours is greasing required or is maintenance required? Pallet changes that we just saw, sensor implementation of temperatures, alignment, positioning, etc. Data collection to improve our process, improve customer processes. Customer support through robotic process automation, chatbots, predictive maintenance, and all these things, and a lot more. And these are some of our customers and our vendors that we work with today. And with that, I would like to end my presentation. Thank you so much for being here. Thank you for sitting with me to the end. Really appreciate the opportunity to present and talk. Thank you.
Thank you, sir, for your wonderful and inspirational presentation. Now I would like to request Dr. Murli Mohan, sir, Department of Mechanical Engineering, to deliver vote of thanks.
Good morning, Vanada. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion. I, Shumbrali Mohan Reddy, Assistant Professor, Department of Mechanical Engineering, on behalf of organizing committee, convey my deep regards and hearty thanks to our Honorable Chairperson, East Point Group of Institutions, Srimati B.M. Ramadevi Madam, and CEOs Sri S.V. Pramod Gowda sir and Rajiv Gowda sir for their support in their office. I also extend my thanks to Sri Peter Francis sir, Secretary, MG Charitable Trust, in his absence here. My sincere thanks to our Senior Vice President, Dr. Prakash sir, for various help we received towards this conference. We are all inspired by your great words. Thank you, sir. I would like to thank our beloved principal, Dr. Mrityunjaya sir, for his support. I thank our vice principal, Dr. Yogesh sir, for his constant support and guidance. On behalf of the entire EPCET, I would like to express my deep gratitude to our chief guest, Sri Girish sir, MD Girish Ventures and Chairman, Indian Concrete Institute, for accepting our invitation and for being here with us. Your thoughts have truly inspired us. Thank you, sir. My special thanks to guest of honor for today's event, Sri Tapan Chaudhary sir, CEO and MD, Architect Precision Systems, for taking his valuable time out and ensuring his presence here. Sir, your speech has inspired the gathering of scholars and students to excel in their chosen domains. Thank you, sir. I think the HOD of Mechanical Engineering Department and Civil Engineering Department. Thank you, sir. I am thankful to all the participants for coming here and attending the event. And last but not the least, I am very much thankful to all our faculty members and non-teaching staff of Civil and Mechanical Engineering Department for their constant support for making this event a successful one. Thank you, Vananda.
Thank you all. The high tea has been arranged outside. All can join for a high tea. After high tea, the participants from mechanical department can assemble in second floor mechanical block seminar hall, and civil students can assemble in CAD lab first floor mechanical block. Thank you all.